Sometimes when you compose a function, it can change the restrictions on a function's domain and range. So that happens in this next example here. We're going to determine two functions, h and k. Again, I'll do one in blue and the other in green. So let's do h first. This would be f of g of x. So we're going to put g of x inside of f. Can you see what it should be?
The square root of x squared subtract 1, right?
Sorry, say that again.
Square root of x squared subtract 1.
Square root of x squared minus 1. Yeah, right? You take f of x, this function, and wherever you see x, you replace it with g. Does that make sense, Riley?
What do you do with the square root? Oh, it's in
This is just the first step.
Yeah.
Good? Okay. And then k of x. Now we're doing the opposite. Right? Now we're starting with g. And wherever you see x, you put this whole thing in for x. So what would that look like?
x minus 1.
X minus 1. Good job, yeah. Right? You have the root of x minus 1 all being squared. See that? And whenever you square something that's being square rooted, it undoes that square root and you just get plain old x minus 1. Follow?
Yeah.
This question also asked, are composite functions commutative? Do you know what commutative means? No. Commutative, I'll show you an example of commutation. 3 plus 4 is 7. 4 plus 3 is 7. You can rearrange the numbers in the addition operation, and you get the same answer.
So they're not commutative.
Multiplication is also commutative. 3 times 4, 4 times 3, same thing. Division is not. 3 divided by 4, 0.75. 4 divided by 3, 1.3 repeating. Not commutative. Same with subtraction. 3 minus 4, 4 minus 3. Not commutative. Right? So composition is not commutative either. Right? I swapped f and g, right? Right here and right here. And I got different results. That means they're not commutative. Okay? Alright, so let's look at the domain and range of each of these functions and see what happened. Okay? So the domain of f of x, what would that be? What numbers can x be? Everything greater than greater than or equal to positive 1. Right? So x such that it has to be greater than or equal to positive 1 and it's a real number. And the range? Square root something, you'll always get either 0 or something bigger, right? So that has to be greater than or equal to 0 and a real number. X squared, that's pretty simple for domain and range. Should be everything for x, right? What about the range? Everything greater than 0. Good. H of x, we had the square root of x squared minus 1. Here's an interesting question. What's the domain? So, because it's a radical, x squared minus 1, the inside stuff, has to be bigger than or equal to 0. And if you think about what that looks like in a parabola, you have a parabola like this that crosses at 1, 0 and negative 1, 0, right? And you're concerned about the x values that allow the function to be above the x-axis. So that's this wing right here, this wing right here. So it's everything to the right of 1 to the left of negative 1. Does that make sense? So in that case, I'm going to have to write pretty tiny here. Our domain is everything less than or equal to -1 or greater than or equal to 1 and all real numbers. Okay? And then the range, again, you're square rooting stuff, so you'll either get 0 or something bigger, so the range doesn't change. Follow? And then k, what was the function for k? X minus 1. That's everything in both directions.
But don't you have to do the restrictions for the original equation?
Right, yeah, no, you're right. Yeah. So the original equation would have been everything has to be greater than 1 or equal to 1. Because we have a radical here to start with.
Isn't it -1?
No.
Oh wait, yeah.
Yeah, positive 1. And x is a real number. And then the y values, you have something that's 0 or above and being squared, so y has to be greater than or equal to 1 or 0.
0,
Yeah.
Okay.
Yeah, so that's an interesting graph, right? It's this line, x minus 1, but with this chunk taken out. Maybe I should just scribble it out. This chunk is taken out because of the way it was originally set up, right? Because you had a radical in the beginning, x has to be bigger than 1. There's 1 right there. And y has to be bigger than 0.